Hello guys, welcome to Math City with Miss G. In this video, we are going to talk about triangle congruence using SSS or side in the coordinate plane. We're given with coordinates, we're going to determine whether the triangles PQR and triangle XYZ are congruent. How do we do this? We're going to find the distance. We're using the distance formula to find the distance between each coordinates that are given. So we're going to start with segment PQ. So I'm going to list down the coordinates on the side, P with coordinates 5 and -4, and Q with coordinates -3 and 7. So using the distance formula, the first step is to label the coordinates. So we will have x sub 1, y sub 1, x sub 2, y sub 2. And then we are going to substitute this in the formula, which is on this corner of the notes. So first we're going to put the square root symbol, and we've got x sub 2, which is -3, minus x sub 1, which is 5 to the second power, plus y sub 2, which is 7, minus -4 to the second power. We'll simplify. This will give us -8 to the second power plus 11 to the second power. Simplifying the answer, we will have square root of 64 plus 121. And adding these two numbers, we will have square root of 185. So we're going to skip our answer as a radical. We're going to move on to the next step. So we have Q with -3 and 7 as coordinates, and then R with 0 and 2. So I am going to introduce a different way of finding the distance aside from using the distance formula, and we should be able to get the same answer. So this is another method in finding the distance. So I'll do the top minus the bottom. That means -3 minus the bottom, which is 0. So I know I am subtracting my numbers, my x values, -3 minus 0. Those are my x values. Then my y values are 7 and 2. So I'll do 7 minus 2. So I am not using the distance formula. I am using a different method. But we should come up with the same answer whether we use the distance formula or the method I am showing. So -3 minus 0 is -3 square, plus 7 minus 2 is 5 square. And in adding the answers that we will get, we will have 9 plus 25, which is equal to square root of 34. All right, moving on to the next one, and that is PR. So P with coordinates 5 and -4, R with 0 and 2. So we'll do 5, my x values, 5 and 0. So I'll do 5, which is my top number, 5 minus the bottom number, and then square, plus -4 minus 2 to the second power. So this will give me 5 to the second power plus -6 to the second power. So simplifying this will give us square root of 25 plus 36. When simplified, it is equal to 61. Let us move on to the next one. So ordered pairs for x and y. So x with coordinates -2 and -1. Y, which is 9 and 7. So -2 minus 9 to the second power. And then -1 minus 7 to the second power. Simplifying our answer, we'll have -11 to the second power plus -8 to the second power. And we will have 121 plus 64, which is equal to 185. All right, moving on to the next one, we will have y with coordinates 9 and 7, z with coordinates 3 and 2. So we'll have 9 minus 3 to the second power plus 7 minus 2 to the second power. Again, I am not using the distance formula. I am using a different way to find distance by putting my x together, subtract top minus the bottom, and then square it. And then same thing with the y values. We should come up with the same answer if you use the distance formula. Moving on, we've got 9 minus 3, which is 6 squared, plus 5 to the second power. So this will be 36 plus 25. So our final answer for YZ is 36 plus 25, that is 61. So square root of 61. And the last side, which is XZ. So we have X with coordinates -2 and -1. Z with coordinates 3 and 2. So we have -2 minus 3 to the second power plus -1 minus 2 to the second power. So -5 to the second power plus -3 to the second power. So this will give us 25 plus 9, which is equal to square root of 34. Oops, 34. Now, if we are going to look at the answer that we have closely, we have 185 and 185. We also have 34 with 34. And the last one is square root of 61 and square root of 61. That means we have 3 pairs of congruent sides. So then we can say, and we are going to make our conclusion, are the triangles congruent? The answer is yes. Segment PQ is congruent to segment XY, and segment QR is congruent to segment XZ. We also have segment PR, which is congruent to segment YZ. So since we are able to come up with 3 congruent pairs, congruent sides of the triangles, then we can use SSS, which means side, 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 to prove that triangle PQR is congruent to triangle YXZ. All right, let's try one more problem that is similar to this. Let's go ahead and find the distance of each of these numbers. So I am going to write, if you like to use distance formula, I'm going to write it over on this side of the screen. So we have x sub 2 minus x sub 1 to the second power plus y sub 2 minus y sub 1 to the second power. Again, you can use the distance formula because we're finding distance, or you can follow the method that I am showing. So we're going to find the distance from P to Q. So P with coordinates -7 and -1, and Q with 4 and 9. So that would be -7 minus 4, my x values, plus -1 minus 9. So this will be -11 to the second power plus -10 to the second power, which when simplified is equal to square root of 221. All right, moving on to the next one, we're going to find the distance from Q to R. Q with coordinates 4 and 9, and R is -2 and -5. So 4 minus -2 plus 9 minus -5. So this would be 6 square plus 14 square. Simplifying this number, we will come up with square root of 232. Now moving on to the next one, this time we've got P and R. So P with -7 and -1, R with -2 and -5. My x values are -7 minus -2, and my y values top minus the bottom, so I have -1 minus -5 to the second power, so which will give me -5 to the second power plus 4 to the second power. So simplifying the answer, 25 plus 16, which is equal to square root of 41. Now moving on to the next one. This time we have x and y. So x with coordinates -11 and 4, y with 0 and -6. So -11 minus 0 and 4 minus -6. So 11, -11 to the second power plus 10 to the second power. Simplified, it's 121 plus 100. That is equal to square root of 221. Moving on to the next one, we have y with 0, -6, z with -1 and 3. 0 minus -1 square plus -6 minus 3. So this will be 1 to the second power plus -9 to the second power. When simplified, this is equal to square root of 82. All right, one last side. Now this time it is x and z. So x with coordinates -11 and 4, and z with -1 and 3. So -11 minus -1 plus 4 minus 3. So we'll have -10 to the second power plus 1 to the second power. So when we simplify, we will have square root of 101. Now, if you have noticed, look at the answers closely. We'll have square root of 121 and no, 221 and square root of 221 are congruent. These are the congruent sides, while all the rest are different sets of numbers. So then therefore, this is an example of triangles that are not congruent. So then we can say these triangles are not congruent. Why are they not congruent? Because they do not have 3 pairs of congruent sides. So we're using side, side, side as the triangle congruence to determine if 2 triangles are congruent. So we are looking for the measurements of the sides. And so the measurements of the sides must be equal for us to say they are congruent. And there should be 3 congruent pairs. I hope you find value in this video. Thank you so much for watching. I'll see you in my next one. Bye.